question number 81, which says that the bond strength in CO, CO2 and CO3 2- follows the order. So first of all, what is the relation between bond strength and bond order? Bond strength is directly proportional to bond order. So now if I see these molecules, we have carbon monoxide. So in carbon monoxide, the bond order is 3. Now we have carbon dioxide. In carbon dioxide, the bond order is 2. And now we have CO3 2-. So CO3 2- has this structure and it has the resonating structures. So it is CO negative, C double bond O, O negative, and we can have one more resonating structure. So there are 3 resonating structures for CO3 2-. So how to calculate the bond order? I have already discussed to calculate the bond order of such type of species. So the bond order is equal to number of covalent bond divided by number of resonating structures. So number of covalent bonds here are 4 divided by resonating structures. It is 3. So it is equal to 1.33. So the correct order of bond strength will be CO and then CO2, and the least will be for CO3 2- as it has the least bond order. So option number 3 is the correct answer. So moving on to the next one now, we have question number 82, which says that the compressibility factor of a gas is less than unity at STP. Therefore, so if I talk about an ideal gas, the molar volume of ideal gas at STP is 22.4 liters and the real gas shows deviation from the ideal gas. So here it is given that the compressibility factor is less than 1, which means that there is greater intermolecular force of attraction in the gas molecules. So due to the presence of greater intermolecular force of attraction, the volume will be less than the molar volume of the ideal gas. So for Z is less than 1, we have molar volume less than 22.4 liter. And if you have, suppose Z is greater than 1, which means intermolecular force of attraction are very less. So here the molar volume will be greater than 22.4 liter. So here the answer will be equal to option number 3. So moving on to the next one, we have question number 83, which says that in which of the following both magnetic moment and bond order decreases. So for this type of question, we need to use the molecular orbital theory. So in the first case, O2 negative is being converted into O2 2-. So the bond order of O2 negative is equal to 1.5. And for O2 2- it is equal to 1.0. So in this case, and O2 negative is paramagnetic due to the presence of one unpaired electron in the pi star molecular orbital, and O2 2- is diamagnetic. So here you can see that bond order is decreasing and magnetic moment is also decreasing. So this option is absolutely correct option. So now if I talk about second option, means CO plus is being converted to CO. So CO plus bond order, as we have discussed earlier also, it is 3.5, and for CO the bond order is equal to 3.0. And also CO plus is paramagnetic as there is one unpaired electron present, and CO is diamagnetic as no unpaired electron is present. So here also the bond order is decreasing and magnetic moment is also decreasing. So option number 2 is also correct. Now if I talk about the third option, in which N2 is being converted to N2 positive. So bond order of N2, as you know, it is equal to 3. So when electron is removed from the bonding molecular orbital, so the bond order will decrease, that is 2.5. And N2 is diamagnetic and N2 plus will become paramagnetic. So here the bond order is decreasing but the magnetic character is increasing. So this is our incorrect option. So both 1 and 2 options are correct. So option number 4 is the correct answer. So moving on to the next one now, we have question number 84, which says that the density of neon will be highest at. So use the expression that we have Pm is equal to dRt. So we can write the density is equal to Pm by RT, where P is the pressure and T is the temperature. And molar mass of neon and the value of R is constant. So D, we can say that D is directly proportional to pressure and inversely proportional to temperature. Means we have to increase the pressure and decrease the temperature so that we can get the maximum value of density. So you can see in the second option, we have the pressure is highest, that is 2 atmosphere, and temperature is lowest, that is 0 degree Celsius. So option number 2 is the correct answer. So moving on to the next one, students, we have question number 85, which says that the number of d pi p pi bonds present in cyclooctatetraene is. So first of all, draw the structure for cyclooctatetraene. So we can draw the structure for cyclooctatetraene. Means there are 4 pi bonds present. And now we have to identify the nature of pi bonds present. So you can see here the pi bond which is formed between the carbon atoms, it is 2p pi p pi. There is no possibility for d pi p pi bonds. So as no vacant d orbital is present in the carbon, so we have only 2 pi p pi bonds, not d pi p pi bonds. So option number 3 is the correct answer. Means we have 0 d pi p pi bonds present in cyclooctatetraene. अगर वो पूछते how many p pi bonds are present, so answer would be 4. So here option number 3 is the correct answer. So moving on to the next one,